In this video, we are talking about how to solve one-step equations, including integers. We have a few examples to go over, so let's get started. What we're trying to do when we are solving for variables is isolate the variable. So a variable is just a letter that is in place of a number that we don't know yet. So this x is some number that when we add it to 5, then we get 37. So with one-step equations, you might be tempted to just try to figure out what this is without actually showing the work to solve these. But as you're learning how to solve equations like this, I really encourage you to go through the steps of solving these by undoing operations to isolate the variable and get it by itself, because these types of equations will get more complex as you go. So this is a really great foundation for that. All right, so let's see what we have to do here. A lot of my students like to draw a line down through the equal sign. That gives us a left side and a right side. And basically what that does is it helps us to remember that whatever we do to one side of the equation, we have to do to the other side of the equation. So like I said, we want to get this x by itself. Right now, 5 is being added to it. So in order to undo addition, we want to subtract that 5. Whenever something is being added or subtracted to the variable, we want to cancel it out to 0, meaning that we want to do whatever it takes to get this that is being added or subtracted to the variable to equal 0. So in this case, that's going to be subtracting 5, because positive 5 minus 5 equals 0. Now, whatever we do on this side, we have to do on this side as well, because this is an equation. Each side equals each other, right? That's what the equal sign means. So if we take away from one side, we have to take away the same amount from the other side. All right, so let's see what we've got. This is going to cancel out, so I like to just cross this out, and we're going to drop down our x, drop down our equal sign, and then we need to solve this side. So 37 minus 5 gives us 32. All right, and then now that we have this x by itself, there's no other numbers or anything with it, it's not negative, we are done, and we have our solution to this first equation. Let's see what we've got for problem 2. Now here's our variable, it's b, and 8 is being subtracted away from b, and then all of that equals negative 26. All right, so again, let's just draw our line down through the middle, through the equal sign. And how are we going to undo this subtraction of 8? Well, the opposite of subtraction is addition, and a negative 8, if you want to think of it like a negative 8 plus a positive 8, that would give us 0, right? And that's our goal here, is to get this part to equal 0, whatever is with the variable. All right, and that means we're going to have to add 8 to this side of the equation as well. So this is going to cancel out here. We're left with just b on this side. And then negative 26 plus 8. I do have a video about adding and subtracting positive and negative integers. I'll link that in the description below. But there are lots of methods. This is the method I like to use. The 26 is negative, so I'm going to put that in this column. The 8 is positive, so I'm going to put that in this column. When they're in opposite columns, they have opposite signs. We're going to subtract the larger number minus the smaller number. So 26 minus 8, that gives us 18. And then, so I'm going to go ahead and write down 18. And then our larger absolute value, the absolute value of negative 26, is in the negative column. So then that is what our answer is going to be, is a negative 18. Okay, let's take a look at number 3. We've got negative 4y equals 64. All right, so a few things to talk about here. This negative 4 is being multiplied times y. Whenever you see a number and a variable just kind of smooshed together, then that means that they are being multiplied. When you don't see a symbol in between, then that always means multiplication. So just like we see down here, 8x is the same as 8 times x. Okay, so now we know that we're dealing with multiplication and we need to undo that multiplication, right? Because this is our variable right here. Then I'm going to split my equation down through the equal sign. So to undo multiplication, we're going to use division. Now, I'm going to write it like a fraction because a fraction is just the same thing as division, right? Whenever a number and a variable are being multiplied or divided, the way that we want to cancel this out is to cancel it out to 1. We want to wind up with 1y, not 0y, because 0 times anything, no matter what y would be, is going to equal 0. So that's not going to give us a true answer. We want 1y on this side of the equation. So we are going to divide by -4 because -4 divided by -4 is going to give us 1. Okay? And we're going to do the same thing on this side, 64 divided by -4. All right? Okay, so these are going to cancel out here. So you can write 1y, but when we're writing variables with a coefficient of 1, then we typically just write just the single variable by itself, which is what we want, right? We want that y to be by itself. That's our goal here. All right, and then we need to divide this. So 64 divided by -4, we have opposite signs, so that means our answer is going to be negative. And I do have a video on this as well, multiplying and dividing integers. I'll link that as well. So 64 divided by 4, 4 can go into 6 one time. And then we bring down our 4, 4 can go into 24 6 times. So we wind up with -16, y equals -16. By the way, we can always check our work, and that's a good idea to do, especially when you're first starting out. So I'm going to actually go up to the first problem and show you how to check your answer check your solution to see if it's correct. So I'm just going to rewrite my original equation. So we've got x plus 5 equals 37, and we solved this to figure out that x would have to equal 32. Well, now I'm just going to substitute in 32 for x and write everything else in. Now we just need to solve this side of the equation. So 32 plus 5 does equal 37. So as long as we wind up with the same number on both sides of the equation, then we've checked our solution and we know that we got the correct solution. Let's go on to number 4. We've got m over 8 equals 10. Now remember, a fraction is just another way of writing division, right? So a over b is the same as a divided by b. So we're going to treat this like m is being divided by 8 so that we can figure out what operation we need to use to undo that division. So the opposite of division is multiplication. So we are going to multiply this whole fraction times 8. And whatever we do to one side, we have to do to the other. Now, sometimes with fractions, it gets a little bit confusing. Students might want to do 8 times 8 and get m over 64. But that's not actually what's going to happen here. Remember, we want this 8 to go away. That's our goal in multiplying by 8. So what we're really doing when we're multiplying a whole number times a fraction, we want to put that whole number over 1 and create a fraction. Now, when we look at it this way, it might appear a little bit more clearly that these 8s are going to cancel out with each other, just giving us 1 and 1. So this actually gives us m over 1 or just m. Anything over 1 we can actually just write as just that whole number. So let me actually write it like this. So I'm just going to drop down that m. My 8s have canceled out. And then over here, 10 times 8 gives me 80. So that is our solution for this one. All right, let's take a look at problem 5. I wanted to write this one a little bit differently than the first 4. When you're first learning this skill, a lot of times you will see a variable and then some operation happening with that variable over on the left side of the equal sign, and then just a single constant number on the right side of the equal sign. So in problem 5, we have the opposite of that, right? We have our variable over here on the right side of the equal sign, and 9 is being subtracted away from whatever a is, right? But we're still going to use the same process. It's okay that the variable is on the right because this equal sign just means that this side is equal to this side, right? So it doesn't matter what side it's on. If we have an equal sign in between, it means this side is the same as this side. So let's see what we need to do to undo any operations that are happening with our variable here. So a minus 9, we need to undo that subtraction. So the opposite of subtraction is addition. So we're going to add 9 because we want this to cancel out to 0 and just go away. We don't write the 0 as part of our solution because we want it to be simplified. We don't want to, we could technically write a plus 0 down here, but we want it to be more simplified than that. All right, and then let's add 21 plus 9 over here. That gives us 30. So that is our solution for number 5. 30 equals A, or A equals 30. Okay, on to number 6, our last problem here. Again, we've got the variable over on the right side of the equal sign. And this time the variable is the very last term, and the variable is being added to the constant. With addition, though, we know that we can add in any order, right? 12 plus k is the same as k plus 12. Or if we want to think about it with integers, 3 plus 5 is going to give us the same result as 5 plus 3. So when we are trying to solve this, we just want to notice what signs are in front of each term. The 12 doesn't have a sign in front of it, so that means it's automatically a positive integer. So in order to make this positive 12 equal 0, what do we have to do? We have to subtract 12 away. So sometimes that can get a little confusing because students see this plus sign and think that that's why we're subtracting. We'll get into that with our two-step equation video, which is coming after this, where if we have a positive number minus a variable, that's going to work a little bit differently. We'll get into that in a different video. All right, so let's subtract 12 from both sides of the equation. That's going to cancel out our 12 here, equaling 0 plus k, or just k. And then equals, and then 33 minus 12 gives us 21. So that is our solution for that one. Thanks so much for watching this video. I hope it helped you. If it did, please give me a comment below. A like and a subscribe is also great. That really does help me to keep making these math videos. This is part of my pre-algebra series. I have a ton of videos going over all of the skills that you might typically see in a pre-algebra class. So check that link out in the description as well, and I'll see you next time.